So I'm here at Ozwater today, and I've got Matt and Stefano with us from QUU. I might just get you to introduce yourselves and what your roles are at the moment.
So my name is Stefano Freguia. I'm actually from the University of Queensland, but I work very closely with QUU through the Innovation Centre and the partnership that we have. Through that, I'm an associate professor at the University of Queensland at the Advanced Water Management Centre. Been there for 9 years, and I work mostly in urban wastewater management and the link between centralized and decentralized solutions to make our urban wastewater systems more resilient and prepare for a future where we will have increasing urbanization and more water stress.
I'm Matthew Mulliss. I'm Engineer Resources at Queensland Urban Utilities. My role is to identify the opportunities and potential benefits of resource recovery for our sewage treatment systems, for example, recycled water, biosolids, other opportunities within the network to recover nutrients such as struvite, and understanding the broader impact and benefits within our whole servicing system.
Okay, so I understand you've done some work around nutrient recovery from source separated urine. Is that right?
UGold.
Yes, UGold.
So what is UGold?
So UGold is an idea we had a few years ago. It's basically a low energy solution to pull the nutrients out of urine to create a fertilizer. And so while we're creating a fertilizer, we are also treating the urine, and with it basically 80% of the nitrogen and 50% of the phosphorus that goes into our wastewater stream. So we're achieving two things. We are making our wastewater management systems more resilient and stronger, and we're moving towards the circular nutrient economy, where we are actually creating renewable fertilizers, reusable within cities, so that will also promote urban greenings and urban agriculture, all topics that have been talked about quite a bit in this conference.
So for a utility like QUU, urine, as Stefano mentioned, is 80% of the nitrogen in our domestic sewage, even though it's 1% of the volume. So actually what we do as a utility, a lot of what we're doing is driven by the urine stream, even though it's basically invisible when it comes in. So it actually drives a lot of our capital and operating costs in terms of chemical, energies, materials, and capital in terms of bioreactors, aeration and pumping. So for us, it gives us flexibility and potentially allows us to buy time and defer large capital investments in our treatment plants.
Okay, so where are you in the process? So you've developed this, and then is there any pilot plants in place, or what's next?
So yeah, we tested it in a lab for about 2 years, and then we moved to the field where we put together a so-called pilot. It's so-called a pilot because it's still pretty small in scale, but it deals with urine from a toilet block, which is used daily by about 40 people. So because urine is not such a large volume, the flows are still pretty small, but that's already quite a scale up from what we had in the lab. So the demonstration of the pilot has concluded, and now we are moving to the next phase, which is taking something successful and upscaling it even further.
So are there any challenges associated with upscaling into a full-scale model?
Well, the question is, what is a full-scale model? Because urine is not collected and taken to a centralized facility, so it's going to always be distributed or decentralized. So it all depends on the number of users for a given facility. So if we are looking at, for example, an office building where you might have a few hundreds to a couple of thousand people working there daily, so that probably is one of the largest scales that we'll be talking about. We'll have real systems that are very small because they are dealing just with a limited number of users. For an airport or a public space such as the city parkland, we might be looking at even larger application with many users, but also the challenge would be the flows will not be even. There will be days with hardly any flow and days with an excess. So we have put together technology which we think would be really robust and able to deal with this variability.
Okay.
Yeah.
Okay, and has this been done anywhere else? Did you say this hasn't been done?
Well, UGold is the world first, so there's a few places where similar technologies have been devised, but really what we have is something really unique, which uses the power of bacteria to create the energy that is needed to drive the process. So it's really unique, and it's really a world first that UQ and QUU have developed together.
Excellent, that's great. So I suppose my next question is around community perception, and what do you see? Do you see that there's acceptance within the community for source separation?
This is a long journey. So for Australia, especially, it will take a long time, and that's why a public demo is absolutely essential. So people need to see it, need to go in there, need to smell that there's no smell, need to realize that it's clean, and realize that it's beneficial. Learn about the circular nutrient economy, learn about water stress and the issues with urban wastewater management, and only that way it will become more acceptable. The path will start from places where people will have less issues, for example, public places, airports, parks, that should be no problem. Then moving to office buildings, people don't mind it so much in their workplace, and lastly, perhaps targeting residential.
Homes.
And apartments in high rises especially. So this, urine separation technologies have been used in Europe for decades. So the acceptance has been a long journey there too. But there are countries where it is accepted. So there's a history that this is a possible journey. So we're just getting started here, so we're looking forward to some progress.
Yeah, very exciting. Okay, well, thank you very much for joining me today, and I hope you enjoy the rest of the conference.
Thank you.
Thank you.